Let's take a look at Boolean operators in Java. Oh yeah. So this is a very simple example here. I'm using the equal operator, and you probably remember this from JavaScript. This is just a test to see if these two values are in fact equal, if they are the same. So this is a comparison. If num1 is equal to num2, it'll write out the numbers are equal, else it'll write out the numbers are not equal. Now, of course, they are not equal. Oh, you can see I already ran it here on the side, but I can compile and rerun it. And in fact, it says the numbers are not equal. And you might also remember that equal, that's different than just saying a single equal. A single equal is an assignment statement. This would actually change the value of num1 to equal num2. And actually, if I ran this, you would see it's going to be, yeah, you can see that I get an error here. It says incompatible types. You cannot be converted. So basically, it's saying this is not a Boolean operator anymore. That's what you want. Now, of course, I could just run it on its own here. I mean, I don't even have to put it in an if statement. I could just say something like, I could just say, wow, look at all this extra junk. I'm going to get rid of all that. I could just print out num1 equals num2. What do you think that's going to do? Does num1 equal num2? Is this a true or false statement? Well, let's see. I think we probably know the answer to that. That is in fact a false statement, right? Num1 is not equal to num2. So of course, you probably know this operator as well. That's also a Boolean operator. This is not equals. So is num1 not equal to num2? Yeah, that's true. They are not equal to each other. So hopefully this is all making sense to you. This is really nothing different than we did in JavaScript. Now, other common Boolean operators that you'll see, of course, are greater than. I could ask if num1 is greater than num2. I could ask if num1 is less than num2. I could do less than or equal to. I could do greater than or equal to. Yes, the greater than and less than always has to come first, of course. You cannot write that. That's going to give you an error. If I compile it, yeah, there's a problem with that. So those should be quite familiar. So hang in there. We're going to do just a few more. Now let's take a look at AND operators and OR operators. So this is an AND operator, and it looks exactly the same as it did in JavaScript. It's just 2 ampersands. So here I'm asking if num1 is equal to 5 and num2 is equal to 10, which they both are. And of course, if I run this, it'll tell me true. And you might recall that an AND gives you true if both conditions are true. So this must be true and this must be true. If I ask this, if I made one of them false and I reran it, compile and rerun it, it would say false. So keep that in mind. An AND condition is only true if both parts are true. Now I could make this an OR condition, of course. An OR condition, exact same as JavaScript, just these 2 vertical lines here. An OR condition is true if either part is true or both parts are true. So of course, if I run this, this will be true. Oops, let me run it. That is true. And obviously, if both parts are true, it's also true, right? I mean, this is also true. Let's run this one more time. I think I ran again. Yeah. One thing, sometimes students don't realize if I wanted to negate a Boolean expression, could just do this, right? Boolean expressions, and perhaps I should have mentioned this, Boolean expressions always return the value true or false, but I guess you probably knew that already. So if this inside value here is true, by adding this exclamation point, that negates it. So this is saying not true, which hopefully should give me false. And run it one more time, and that is false. So just to be clear, an AND statement is only true if both parts are true. But an OR statement here, this expression right here, this OR statement, that's true if either part is true or if both parts are true. That's still true. All right, let's just do a couple more. In this example, I'm showing a common error that students sometimes make. So notice I have 3 integers. They're 3, 4, and 5. So I want to figure out if A is less than B and B is less than C. Will this work? Well, you can see the error popped up already. It says this is a bad operand because the first evaluation, A less than B, this returns a Boolean. This will give me a true false. And so really what I'm saying is true or false less than C, which happens to be 5? Well, that doesn't make sense at all. So you can't just, if I want to see if A is less than B and B is less than C, you can't just arrange them with less thans in between all of them. The correct way of doing this, of course, is saying if A is less than B and B is less than C. So in this case, I think I should get true, right? Because A is less than B, A is 3, B is 4, C is 5, and B is less than C. So if I run this, this will now work. All right, we're going to do just a few more, so hang in there. In these three examples, you have to think about operator precedence. And just like in math where multiplication comes before addition, anding comes before oring. So and has a higher precedence than or. So with that in mind, just give this a thought for a moment. Which of these statements will be true and which will evaluate to false? Or you can pause the video if you like. Have you got them? All right, let's run it and see what the output is. Very exciting. And it is false, true, true. So let's talk about why that is the case. Well, as I said, and has a higher precedence, so this and statement happens first, and of course, false and true is false. So I have false or false, which of course is false, because an or statement is true if one or the other is true. But in this case, neither is true. So that makes sense. So why are these two true? Well, again, it does the and part first. So of course, true and true is true. And true now is being ored with false. So of course, true, I'm sorry, did I say or? I hope I said or. So true or false is true. So that's why this is true. And of course, the last case is true because I'm saying not false, which is true, and true, which is true. So this is true, or false is true because, again, if you have an or statement, if one part of it is true, the whole thing is true. And of course, this first part is true. I hope you hung with me for all of that. All right, I'm going to do one last little example. We're almost there. In this last example, I want to talk about short circuit evaluation. Short circuit evaluation is the way that Java evaluates these Boolean expressions. Java only evaluates a Boolean expression until the truth value is known. And sometimes this can be used to prevent an error from occurring. And I'll show you what I mean in just a second here. So I've declared two values. I have num, which is 0, and sum, which is 100. Now, if I try to run this first case, if sum divided by num, now remember, num is 0. So if sum divided by 0, and you know, of course, you can't divide by 0, that's an arithmetic error, is greater than 50, and num is greater than 0, then do some stuff. Well, this will actually cause an error. And if I compile it and run it, well, it's compiled and run it, you will see that I get an error. It says arithmetic exception, divide by 0. You can't divide by 0. But if I rearrange this, now underneath it, you can see, I rearrange this. I put num greater than 0 first, and then I put the division. So I'm really checking to see if num is greater than 0. And if it is, then I can evaluate this. So the question is, how come this runs without error? Well, again, Java does what is called short circuit evaluation. So as soon as the truth value is known, so in this case, if num is greater than 0, if this was true, then it would do this division. And actually, I'll run this, and you can see that, oops, did I run it? There we go. I will run it, and you can see there's no error occurred. And let me say this again, because it's a little weird. The reason that no error occurred was because this first statement, num greater than 0, was false. And since false and anything is false, right? False anded with anything is going to give me a false. Java doesn't even look at this part. And this was the part that gave me the divide by 0 error. So you can use short circuit evaluation to your advantage. Again, short circuit evaluation means that Java stops evaluating expressions as soon as the truth value is known. So let's look at a very similar example, but with ors. So very similar thing. Basically, I'm trying to prevent a divide by 0. And I know this seems weird, but you are actually going to use this in some cases. So here I said, again, if sum divided by num is greater than 50. Now, of course, you know this is going to evaluate, this is going to give me an arithmetic error dividing by 0 or something else. So this is, of course, not going to work. And I can compile and run it. And of course, it doesn't work. I get an arithmetic exception. But if I do this test first, so let's look at this last example. So again, this last example, I'm saying if num is equal to 0, which happens to be true in this case, num is equal to 0, or num divided by 0 is greater than 50, then do some stuff. Well, this will run without error because this first part is true, right? Num is equal to 0, and true or anything is true. So again, Java does not even evaluate this part. It jumps out of that evaluation. It does what is called short circuit evaluation. And that's, oh, I should probably run this so you can see it run. I will compile and run it. But bam, it runs without error. All right, well, thanks so much for watching, and I guess it's your turn to get to work.